Hello everyone and welcome to Lesson 5 of Algebra 2. Today we're going to be talking about square roots. Not just what a square root is, because you probably already know that, but we're also going to be talking about how to solve equations using square roots. This is one of the tougher things that you will not see in Algebra 1, but you will definitely see in Algebra 2. Or maybe you see it in Algebra 1, I honestly forget. But I promise you'll see it in Algebra 2. So the first thing we're going to do is we're going to talk about perfect squares. And I'm going to give you the list of perfect squares you need to know. Maybe you're wondering, what is a perfect square? I'll tell you as an example. Starting from the very lowest square root we know the square root of 0 is 0. We also know the square root of 1 is 1. And maybe now you're starting to see what I'm getting at here. So think to yourselves, what's the next one? It's going to be root 4 equals 2. What's the one after that? That's root 9 equals 3. And then can anyone tell me what the next one will be? Root 16 equals 4. How about the one after that? Any volunteers? That's going to be square root of 25 equals 5. After that is going to be root 36 equals 6. Root 49 equals 7. Root 64 equals 8. You may be wondering, how high are we going? We're going to go up till 12 today, because I recommend you know up until 12 for the square roots. Next is root 81 equals 9. Root 100 equals 10. What comes next? Root 121 equals 11. And then the last one for 12. Root 144 equals 12. And these are the ones I'd recommend knowing. It's going to help you when we do what we're going to be doing later today. Oh, and by the way, just in general, remember that if you ever have, for instance, a negative square root, we would say does not exist, or no solution, or something along those lines, because you cannot have negative square roots. Now, technically, we eventually in Algebra 2 talk about something called imaginary numbers, which do use negative square roots, but we are not talking about that today. You cannot have a negative square root. Okay, next. For every other square root in the world, like for instance, square root of 24 here, you basically have to do this strategy of coming up with the factors, breaking it down to factors. And the strategy that I'm going to use today might not be the one you're familiar with, but it's the one I use, so I'm going to do it. I like to look for pairs and squares. I look for pairs and squares. So what does that mean? If I, for instance, have a pair of 2's, I'm going to circle them, and that comes out of the square root. Or if I have a perfect square, such as the square root of 4 equals 2, then that gets out of the square root as well. The only thing that gets out of the square root is pairs and squares. Everything else remains. So as an example, let's look at 24. The square root of 24 can break down into root 4 and root 6. Writing the square root here is optional, but I like to write it to remind myself who's inside and outside the square root. Square root of 4 is a perfect square. We know it's 2, and that breaks out. And then the square root of 6, that can be broken up into root 2 and root 3. Which is not a pair or a square, so they stay inside the square root. So in other words, when I write my final answer, this 2 broke out, and then in the square root I have 2 times 3, which can simplify to 2 root 6. And that's my final answer. And that's how I'm going to solve square root problems like this. And by the way, there's more than one way you can break this up. Like for instance, I could have started with root 24. I could have said 24 breaks down into 2 and 12. And then I can say 12 breaks down into root 2 and root 6. And root 6 breaks down into root 2 and root 3. And remember, if I have a pair or a square, it breaks out. I've got a pair of 2's right here. So that breaks out as a 2. And this 2 and this 3 do not break out, so they stay inside the square root. So my final answer is still 2 times 2 times 3, which is still 2 root 6. Same answer. Does anyone have any questions on the strategy I'm using here? No? Okay. Well, then now we've got a bunch more of these to do on the next page. Let's go ahead and do them. And I'm going to walk us through the first couple, and then after a few tries, I'm going to let you do it on your own. So let's start with 45. First, what are the factors of 45? I would say root 9 and root 5. Root 9 is a perfect square. We know that's 3, and that gets out. And then 5 doesn't have any more factors, so that's just stuck inside the square root. So in other words, my final answer is 3 root 5. There we go. Now for root 50. We have root 5 and root 10. Root 10 can be further broken down to root 5 and root 2. And now I have a pair of 5s right there. So the 5 is going to break out. And the root 2 right here is still stuck in the square root. So the final answer is 5 root 2. Now, by the way, one thing I want to mention is that if you, for instance, let's just say, hypothetically, that I had root 2, root 2, root 3, and root 3, and a root 7, something like this. Well, what I want to tell you is that you got a pair of root 2s, so 2 breaks out. You got a pair of root 3s, the 3 breaks out, and you still got the root 7 left over. So what's the answer in this case? You multiply the 2 times the 3 outside the square root, and then still inside the square root is the 7. Whoops, I don't mean equals root 7, just times root 7, sorry. And then the final answer is 6 root 7. So that's what you would do if there was multiple things that broke out, you'd multiply them together. Basically, you want to keep the square roots and the not square roots separate. So next we have number 3. Number 3 is the square root of 28. I would say 28 breaks down into root 2 and root 14. And again, there's more than one right answer. Like, for instance, you could choose 4 and 7 as well. Doesn't matter. And then root 14 further breaks down to root 2 and root 7. We got the root 2's here. 2 breaks out. Root 7's still stuck in the square root. Final answer, 2 root 7. And now for the next 3, I'm going to let you guys try it on your own. I'm going to go over them one at a time, so I'm going to give you a minute for each one, and then we'll go over them. If you want to go ahead a little bit, that's fine. Okay, and go. Okay, I'm going to say time's up for number 4. Did anyone from the audience get an answer for root 56? No? Okay. So here's what I'm going to say. Root 56 can be broken down into root 7 and root 8. Root 7 stuck, but root 8 can be broken down to root 4 and root 2. You can break 4 down if you want, but I also know 4 is a perfect square. It's going to be 2. So, and then that's it after that. So then the final answer is 2 times the square root of 7 times 2, which can be simplified to 2 root 14. And 2 root 14 is the final answer there. So that's it for number 4. Any questions? No? Okay then, number 5 now. Again, try it on your own, and I'll give you another minute for that. And time's up for number 5. Did anyone get an answer? Okay then, let's do it. So 68 is going to be broken down into root 2, and 68 divided by 2 is 34. 34 can further be broken down to root 2 and root 17. Looks like I got a pair of 2's here, which will break out. And so the final answer is 2 root 17. Any questions there? Okay, and then the last one, root 72. Go ahead, try it on your own. I'll give you another minute. And time's up for that one. Did anyone get an answer for number 6? Not doing too hot today. Or at least you're shy, which I get it. So I would not answer either. So root 72 is going to be root 8 times root 9. Root 9 we know is a perfect square. That's going to be 3. And then root 8 can further break down to root 4 and root 2. Root 4 we know is a perfect square. That's 2. So it looks like we have a 2 outside the square root, 3 outside the square root, and a root 2 still inside the square root. So that means the final answer is going to be 2 times 3 times root 2. And 2 times 3 is 6. So 6 root 2 is our final answer. Any questions on any of those? Okay, that's it for the square root portion. Now for the next part, we're actually going to be solving equations that have square roots in them, which a lot of times is tricky. So basically, the fundamental strategy that we're going to use to solve these square root functions that, like you see below, root x plus 12 equals x, the strategy is the secret when you square a square root. In other words, when you square a square root, like root 5 squared, that's root 25, right? Which is 5. In other words, it looks like when you square a square root, they cancel and you're just left with the number. And so that's going to be the secret. What happens when you square something under a square root? They cancel each other out. They cancel each other out. And so what that means is when I square a square root, like for instance x minus 6 squared, well, the square root is just going to go away. You're just left with x minus 6. And that's pretty cool. And that is the fundamental reason why we're able to solve square root problems. So now looking at the example below, I tell you exactly the 3 steps you need to solve square root problems. Step 1, you're going to square both sides. It's the very first step. Square both sides. Step 2, you're going to solve for x, and you do that using just normal algebra. Sometimes you're going to have to factor. There's actually going to be a lot of factoring today. No quadratic formula, though. Just letting you know now. And then step 3, well, let's actually do steps 1 and 2 first for this one. X plus 12 equals x. Square root of x plus 12 equals x. So the first thing I'm going to do is I'm going to square both sides. On the left side, square root and squared cancel. I get x plus 12. On the right side, I get x squared, which is, well, just x squared. And now I have to solve this equation. Does anyone know how I'm going to solve this equation? So the secret is, whenever you have x squared, like right here, you need to set it equal to 0 first. That means I need to subtract x and subtract 12 from both sides, and I'm going to get 0 equals x squared minus x minus 12. Now it looks like a factoring problem like how we saw in week 2 or week 3. And how do I factor this? Well, first I'll set up my 2 parentheses, right, when I factor. And the factors of 12, I've got 1 and 12, I have 2 and 6, and I have 3 and 4. And then I need them to subtract to negative 1 in the middle. So that tells me I'm going to probably choose 3 and 4 because 3 minus 4 is negative 1. So that's what it's going to be. The factors are positive 3 and minus 4. And if you're unsure of that, you can always check your answer by foiling. And that's how you can check your answer. So it looks like we get 2 solutions. X equals negative 3 and positive 4. Because remember, the solutions are just the opposite of the factors. And it looks like we're done. Except you need to do step 3, which, and this happens whenever, basically you have to check whenever you square both sides. You need to check for extraneous solutions. Extraneous solutions. What on earth does that mean? An extraneous solution is like a fake answer. In other words, it looks like the answer, but it's actually wrong. And how do you check for extraneous solutions? You check for extraneous solutions by plugging each x back into the function. Plugging each x back into the function. So what that means is, if let's say I have x plus 12 square root equals x, first I will check x equals positive 4, which means I'm saying square root of 4 plus 12 equals 4. And we don't know if this is true yet, like we're checking it. So 4 plus 12 is root 16 equals 4. Is that true? What's the square root of 16? Well, that's 4. So 4 equals 4. Check. We're good. 4 is a true solution. Next, we're going to check x equals negative 3. Let's see what happens here. It's going to be square root of negative 3 plus 12 equals x is negative 3. And so what I would say is square root of negative 3 plus 12, that's square root of positive 9 equals negative 3. And what's the square root of 9? It's 3. And 3 does not equal negative 3. So negative 3 is not a solution. The only solution I have is x equals 4. You need to cross out x equals negative 3, or in the very least, just circle x equals 4. You can't circle both. And why does this extraneous solution stuff come up? It comes up whenever you square both sides, like in a square root problem. The other thing I want to tell you is that you could have 0, 1, or 2 solutions. In this case, we had one solution. Both of them could have worked. It's also possible that neither one could work. All three are possible. Are there any questions on anything I just said for this example? Okay. Now there's one thing I do want to point out, and I'm going to say it now because I'm going to mention it later and it's important. Basically, there's 2 facts we need to know. Kind of 3 facts. The first fact is when you square a negative number, it becomes positive. So when you square a negative number, it becomes positive. And maybe you knew that before, maybe you didn't. But the reason why this is true is because let's say I have negative 2 times negative 2. The negatives cancel and you get positive 4 because 2 negatives make a positive. So that's one thing we need to know. The other thing we need to know, and this one's confusing, I mentioned earlier that you cannot take the square root of a negative number. This would just be does not exist, like we said before. But if you're solving an equation, and let's say you have x squared equals 9, for instance, or maybe I'll just use 3 because that was the example I used above. If you have this and you square root both sides, this is going to be plus or minus 3. Okay? When you square root both sides, the answer is plus or minus, we say. And we need to remember that. When you square root both sides, the answer is plus or minus. And as always, for those of you watching the recording, I want you to be writing along as well. That's why I'm taking these pauses. And also why this is confusing is, let's just say hypothetically, I ask you, what's the square root of 16? You would say 4. You do not say plus or minus 4. And that's confusing because didn't I just say it should be plus or minus? No. You only do that when you take the square root of both sides. Let me show you the difference. The difference is, this one I gave you the square root. It was in the problem. In this scenario, I didn't give you the square root. You're taking the square root yourself. And when you do that, that's when it's plus or minus, and you'd get plus or minus 4 as your answer. That is an important difference. I know it's confusing. Is there any questions on that? A good rule of thumb is if you see x in the problem, like x squared, and you took the square root, that's when it gets plus or minus. If you just see a normal square root like this, don't do plus or minus. There's no x nearby. So if you mess that up, just let me know and I'll try and straighten you out. Okay? But in the meantime, we're going to continue. Solve the radical equations. Check for extraneous solutions. By the way, these are called radical equations. Why? Because what does the word radical mean besides super cool? Radical means square root. So these are called radical equations. If you want to look up more of this on your own after today, like the scholar we all know you are, then yeah, you can Google radical equations, practice problems with solutions, or whatever you want to do. So as always, step 1, square both sides. When I square a square root, like the left side, they cancel. I just get x plus 1. And on the right side, I get 4 squared, which is 16. And so then all I need to do is subtract 1 from both sides. X equals 15. That's my only solution. But I'm not circling it yet because I still have to check if it's extraneous or not. Check x equals 15. So that means the square root of 15 plus 1, I'm checking if that equals 4. And that's going to be root 16 equals 4, and that is true. So it looks like x does, in fact, equal 15. Any questions there? Okay, then, let's keep going. So for the next one, we got square root of 2x minus 4 equals negative 2. Again, the first step, square both sides. I'm going to square both sides. So on the left side, we've got 2x minus 4, because they cancel. And on the right side, remember, a negative number squared becomes positive. That's what we were saying earlier. So that's going to be positive 4. So then if I want to solve for x, this is easy algebra. First, add 4 to both sides. 2x equals 8. And then you divide both sides by 2, and you'll get x equals 4. And once again, I need to check x equals 4 by plugging it back into the equation. So that's going to be the square root of 2 times 4 is 8 minus 4 equals negative 2. 8 minus 4 is root 4. Does root 4 equal negative 2? No, it does not. Square root of 4 is 2, positive 2. And it does not equal negative 2. So that means x equals 4 is not a solution. So then what do we write? Do we write nothing? You should write no solution. Don't keep it blank. Write no solution and circle that. That's what you do if that happens. Any questions there? Okay, fantastic. Now on to number 3. For number 3, we have the square root of x squared plus 7 equals 4. As you imagine, the first step, square both sides. On the left side, I have x squared plus 7. On the right side, it's 4 squared, which is 16. The best way to solve this, there's 2 things I can do. The best way, though, is I can subtract 7 from both sides. X squared equals 9. And now I take the square root of both sides, and square root of 9 is 3, so x equals 3. Can someone tell me what I just forgot? I would accept 2 right answers, actually. Okay, so the first thing you may be saying is you didn't check for extraneous solutions, which is true, I didn't get to that yet. But the more important thing I forgot on purpose is I took the square root myself with this x squared. This is when you get plus or minus. So in other words, it's not 3, it's plus or minus 3. Or if you want to write it like this instead, x equals 3 comma negative 3, you can do that as well. And now let's check these 2 answers. So first, I'm going to check x equals 3. To do that, I'm going to say the square root of 3 squared plus 7, and I'm wondering if that equals 4. So the square root of 3 squared is 9, plus 7 equals 4. 9 plus 7, 16, so the square root of 16 equals 4. And that's true. Square root of 16 is 4. Now I got to check x equals negative 3. And for that, I'm going to say square root of negative 3 squared plus 7. Does that equal 4? So remember that a negative number squared is positive. So it's root 9 plus 7 equals 4. And then that's root 16 equals 4. It's the exact same thing. They both work. So in other words, when I go back to my first page and I get this answer, I'm circling both. They both work. And so I have 2 solutions. Any questions there? Okay, good. Now for the next one, for number 4, why don't you try this on your own? I'm going to give you a minute for that, and then we will reconvene and talk about it. And if you're watching the recording, just pause the video. And time's up. So maybe you didn't have time to finish, that's okay. But here's what I'm going to say. First, you're going to square both sides like we've been doing. So then you get square root and squared cancel. 4x minus 3 equals, and then x squared, that's just x squared, just like that. So now this is quadratic. This has got the x squared in it. That does not mean quadratic formula. It means you set it equal to 0 and solve. That means I got to subtract 4x and add 3 to both sides. So I get 0 equals x squared minus 4x plus 3. And now I have to factor this. Well, first I'll set up my factors like this. There's only one pair of factors for 3. You've only got 1 and 3 to choose from. And since that's positive 3, and that's negative 4 in the middle, it means they're both going to be negative. And that makes sense because negative 3 minus 1 is negative 4, which is what I want in the middle. And if you're not good at factoring, I'd refer you back to, I forget if it was lesson 2 or 3, where we talked about factoring, but you really need to have this stuff down, which is why those lessons came before this one. So we have x equals 3 and positive 1. Now we've got to check these answers. So first, I'm going to check x equals 3. So that would be square root of 4 times 3 is 12 minus 3 equals 3 squared. So 12 minus 3, that's root 9, equals, oh, whoops. Oh, I just made a mistake. I squared the 3, right? Like I squared the x. So when I'm actually plugging in, don't plug in x squared, just plug in 3. That was my bad. So in other words, we just have 3 on the right side. Root 9 is 3, so 3 equals 3. Check, we're good. And now if I want to check x equals negative 3, I'm sorry, why did I say negative 3? I meant positive 1. Now if I want to check positive 1, I would say square root of 4 times 1 is 4 minus 3, and I want to know if that equals 1. Well, it looks like the square root of 1 equals 1. Yep, that's true. Check mark. Looks like both of these solutions will work. And one more time, why am I checking for these solutions? Because I never have to do that in algebra, but these ones, it's not optional. I have to check. The reason why is because we squared both sides. Whenever you square both sides, that's when we check. So now number 5, this one I'm not going to ask you to do on your own because this one's harder. But basically the idea is this. Again, you're going to square both sides, okay? When I square the left side, it's easy. It's just 3x plus 4. The square root and the squared cancel. And then for the right side, I actually have to square this. Now the worst thing you could do, this is what a lot of my students do. Don't write this, just watch and don't learn, because this is the opposite of learning. But they will write x squared and then negative 2 times negative 2 is plus 4. And if you write that, you're wrong, because you just squared the numbers individually. That's not what this is. This, x minus 2 squared, is really x minus 2 times x minus 2. In other words, I got to FOIL this. And when I FOIL this, I'm going to get x squared minus 2x minus another 2x and then plus 4, which will reduce to x squared minus 4x plus 4. And then on the left side, I have 3x plus 4. That didn't change. And now if I want to solve for x, again, this is quadratic. It's got x squared in it. We need to set it equal to 0 by moving the left side to the right side. So in other words, minus 3x, and then I got to do minus 4 and minus 4. And that's going to be 0 equals x squared minus 7x plus 0. Since it's plus 0, I don't have to write plus 0. This is fine. And now I would wager that a lot of you don't actually know how to factor this. Does anyone know how? So this is known as GCF factoring, greatest common factor factoring. Basically, you say, what do they have in common? Well, they both have an x in common, right? So that means I factor out the x, and to find out what's left in parentheses, I divide both of these things by x. So x squared over x is just x, minus 7x over x is just 7. That's the factors. And now, what do? You have to say both of these things equal 0. So for instance, x equals 0 and x minus 7 equals 0. Now obviously x equals 0 is already solved. We're done there. And then the other one is x equals positive 7 because you add it to the other side. So right now I have two solutions. They could be wrong. I still have to check them. So first I'm going to check x equals 0. For that I would say it's the square root of 3 times 0 plus 4. And I want to know if that is equal to 0 minus 2. So then on the left side, that's the square root of 0 plus 4 is 4. 0 minus 2 is negative 2. And the square root of 4 is 2. 2 does not equal negative 2. I'm going to cross out x equals 0 because that's wrong. And now I still have to check x equals 7. So to do that, check x equals 7. I'm going to plug in 7. So 3 times 7 is 21 plus 4 equals 7 minus 2. 21 plus 4 is root 25, and 7 minus 2 is 5. What's the square root of 25? Well, that's 5. So it looks like 5 equals 5. Check. It looks like x equals 7 is our only solution. Any questions on that one? Okay, then good. Now, the next one, number 6, is going to be the hardest one of the day. It's the hardest one for two reasons. Number one, it's the hardest one to factor. And number two, I literally wrote it wrong. Like, we're going to have to cross this out. It's not root 7x plus 4. It's actually root 16x plus 4. I apologize for that. But the right side is still the same. So this is actually the problem. I have a typo. So anyways, I'm going to square both sides, as always. Square root and the squared cancel. I get 16x plus 4. And then on the right, 8 minus x squared. Again, I have to FOIL this. So 8 minus x times 8 minus x. 8 times 8 is 64. And then I get minus 8x. And then I get another minus 8x. And then negative x times negative x is actually plus x squared because the two negatives cancel. And now what I got to do is I got to start simplifying. So for instance, negative 8x and negative 8x combine to make minus 16x. And then I still have to set this equal to 0. So in other words, minus 16x and minus 4 from both sides. Make sure you're lining this up correctly. So in other words, I get 0 equals 64 minus 4 is 60 minus 32x plus x squared. And of course, we can write this in the order we're more familiar with, which is to say 0 equals x squared minus 32x plus 60. Now this is the hardest one because there are a lot of factors for 60. For instance, you have 5 and 12, you have 4 and 15, you have 3 and 20, you have 6 and 10, you have 1 and 60, and you have 2 and 30. Now that's a lot. Can anyone tell me what the right factors are? It's going to be, so since this is positive and it's a negative 32 in the middle, it means they're both going to be negative and they have to add to negative 32, which means the correct answer must be 2 and 30 because negative 2 minus 30 is negative 32. In other words, when I set up my factors like this, I'm going to write minus 2 and minus 30. And now I'm getting two solutions right here. I'm getting x equals 2 and positive 30. So now I have to check these, and this is not fun, but we're going to do it anyway. First, we will check x equals 2. I'm not even sure if you have room on your paper to write this, but I hope you do. So we're going to check x equals 2 first. It's going to be the square root of 16 times 2 plus 4. We want to know if that equals 8 minus 2. So 16 times 2 is 32 plus 4. That's going to be root 36. And on the right side, it's just 6. Now the good news is the square root of 36 is 6, which means 6 equals 6. Check. Looks like x equals 2 is correct. And then we just have to check x equals 30. X equals 30. So first, I'm going to have to do 16 times 30, which is not fun, but I'll help you with that. And then plus 4. And I want to know if that equals 8 minus 30. So 16 times 30, you can use a calculator, I don't care. It's 480 plus 4 equals 8 minus 30 is negative 22. So the question is, does root 484 equal negative 22? Well, I assume the square root of 484 is 22. But 22 does not equal negative 22. And for that reason, even if you didn't know the square root, you know it can't be negative. So for that reason, that one does not work. The only answer was the other one, x equals positive 2. That's our only answer. And of course, this was the hardest one of the day, which means the last one we have here should be easier. And I want you to try this one on your own. And for this one, I'm going to give you 2 whole minutes because this one's obviously longer than the other ones we've been doing. So go ahead, try this on your own, and if you're watching the recording, just pause the video. And time's up. So did anyone get an answer, just out of curiosity? Okay. So first thing we're going to do is we're going to square both sides. Square root of the squared cancel, so you get 2x plus 11. And on the right, you got to write it like 2 minus x times 2 minus x. When you FOIL that, you're going to get 4 minus 2x minus another 2x, and then plus x squared. The right side simplifies to, and I'm going to rewrite this in the order I like, which is x squared minus 4x plus 4. And then remember, I need to subtract 2x from both sides and subtract 11 from both sides. So I get 0 equals x squared minus 6x minus 7. And now I got to try and factor this. Well, there's only one pair it can be. It has to be 1 and 7. And since it's negative 6, it's going to be x minus 7 times x plus 1. So our two solutions are x equals 7 and negative 1. And now I need to check both. So first, let's check x equals 7. Check x equals 7. To do that, it's the square root of 2 times 7, which is 14, plus 11. And we want to know if that equals 2 minus 7. So 14 plus 11, that's 25, equals negative 5. Well, we get 5 equals negative 5, and that's not true. So it looks like 7 will not work. And then the next one we'll try is, we're going to check x equals negative 1. Hopefully this will work. And so we're going to get square root of 2 times negative 1, which is negative 2, plus 11. And we want to know if that equals 2 minus negative 1. So on the left side, negative 2 plus 11 is root 9. And on the right, 2 minus negative 1, that's 2 plus 1, because the double negative, so 3. Square root of 9 is 3. 3 equals 3. Looks like we got our answer. X equals negative 1 is the only solution. Any questions on that one? Okay, then great. Well, then that's going to do it for today. Thank you all for watching. Next week, we'll be covering, I forget what, but I'm sure it'll be a great lesson because they're always so great. And thank you all for watching. I'll see you next week. Bye-bye, bye-bye, bye-bye.